Yeah, good evening, all. This is yeah, good evening, all. Welcome back to the Spark YouTube sessions, physics classes. Right, and then in our last YouTube session, we have left electrostatics in the middle, and then we were discussing how to solve simple problems on electrostatics, right? On the Coulomb's law, especially Coulomb's force. Okay, so today we will continue doing the same problems. We will continue learning the same problems, but not on the Coulomb's force. From the same chapter, we will learn how to solve problems in electrostatics on the vector form, like Coulomb's force in the vector form. Like as I told you yesterday, that yesterday we discussed only on those charges which are only two charges, existence of two charges and the force in between the two charges. That is what we have seen yesterday, and I also told you that next time, when we continue this, we will be continuing with the three charges, two or more charges, right? Three or four charges placed nearby, and how to apply that, principle of superposition to find out the net force acting on a charge which is placed there, right? So we'll continue with that. Now, let me introduce myself. This is Anupama, and you are viewing this particular YouTube class from the Spark Academy YouTube channel. Okay, from the Spark Academy YouTube channel, you are viewing this particular YouTube session, right? So, Spark Academy, just we have sparkacademyonline.com. You can just go through that in a web page where you will get every information about, how mm, every information about the courses offered by the Spark Academy and all that. So these are the live sessions. Every day YouTube live sessions will be there. You can attend every day YouTube live sessions, doubt clarification sessions, free material in our app, tips and tricks, and the previous year question papers. Okay, and then admissions are open. Just admissions are open for the 2022 and 23 academic year. You can just go to the Spark Academy page, Play Store, download the Spark Academy app, and then just click on the link given there. It will direct you to the courses which are offered by Spark Academy, and then just whatever course you want to enroll, you can enroll by using that link, right? And so yeah, this is what this. And then, as I told you, we have free sessions, YouTube sessions every day. And you can see here, these are the lecturers who are taking the YouTube sessions, and then these are the classes. This is the schedule every week, weekly schedule, and you can just note down and then join accordingly, right? So as I told you, there are a few courses. If you want to enroll to the courses, then you can just use my code ANU 1010, and then get the discounts which are offered by Spark Academy. Okay, right. So today we are going to learn about electrostatics. Electrostatics numericals on electric field and force, Coulomb's force and electric field. right? As I already told you that electrostatics has 6% of the weightage of the full question paper. Okay, so if you see the previous year question papers, the full 6% weightage will be there, right? So yeah, as important as that. Now, coming to the concept, as I told you, today we will be discussing only about the numericals which helps us in our competitive exams, right? Especially the previous year question papers, questions we will be solving. Initially, we will go with the simple one. Yesterday already we have learned about the Coulomb's law, Coulomb's force, problems on Coulomb's force, right? And today we will continue, but little the next step of it, right? So before we go there, I will again revise the force formula, that is F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. This is one thing, and even here in today's class we are going to learn about the vector form also. Okay, meaning how to apply and how to find out the net force acting on a charge which is surrounded by the number of charges around it. Okay, so that we will be learning here. And apart from that, I also told you we will be solving few problems on electric field too. Okay, electric field E bar is equals to F bar by Q, force acting per charge. That is 1 by 4 pi epsilon naught Q1 Q2 by R square into 1 by Q. 1 Q will go off. Then you get this is as 1 by 4 pi epsilon naught Q by R square. This is about the electric field. So field and force problems we will be learning today. Right. See, the first one, if you take the charges each of 1 microcoulomb are at a point, 2 points. It is P, that is 2I cap plus 3J cap plus K cap meters, and another charge is at Q. This is I cap plus J cap minus K cap meters, right? Then we need to find out the force acting between them. Okay. Any guesses? How will you find out? Anyways, we know the formula, but here R is not given. R is not given. How do you find out R? You know that displacement vector we have already learned, right? R bar, that is R bar is equals to R2 bar minus R1 bar. I think you know this, right? That is, that displacement vector we'll find out and then take the magnitude of it. You will get R, right? That is I cap plus J cap minus K cap minus of 2I cap plus 3J cap plus K cap, right? So you get I minus 2I, how much? Minus I cap. J minus 3J cap is minus 2J cap. Minus K cap is minus 2K cap, right? Or else you can even take plus also. Okay, plus is, anyways, minus or plus in vector, if you are taking the magnitude, that doesn't make any, difference, right? So how do you find out the magnitude for this now? Magnitude of this is equals to under root of 1 square plus 2 square plus 2 square, right? So this will be under root of 1 plus 4 plus 4. This is under root of 9 is equals to 3 meters. So you got R value 3. Means now we got R, right? Then how do you find out F now? It is now easy to find out F. F is equals to 9 into 10 power 9 into What are the charges he gave? 1 microcoulombs, isn't it? That is, Q1 is 1 microcoulomb, Q2 also 1 microcoulomb, right? That is 1 into 10 power minus 6 Q1, Q2 also 1 into 10 power minus 6 only by 3 square. 3 square is nothing but 9. 9 gets cancels. And this is 9 into 10 power minus 12. Right? 9 into 10 power minus 12 is how much? 10 power minus 3 newtons. Right? If you have to find out this in dynes, how will you find out? 1 Newton is equals to 10 power 5 dynes. Right? This is the formula. So we get 10 power minus 3 into 10 power 5 dynes. This is equals to 100 dynes. This is the answer for this question. Okay? I hope this thing is clear. Right? I hope this is clear. So in this way, when they give displacement in the vector form, you will find out it by taking the displacement vector and then take the magnitude of it and then find out the Coulomb force which is given here. This is the simpler one, simpler one. So next one we will see, like, how it goes. Okay. A charge of A charge Q is placed at the center of line joining, two equal charges Q. The system of three charges will be in the equilibrium if Q is okay. There are actually two charges are there. I'll just give hint. I think you can find out this. There are two charges A and B. Two charges are there, and one more charge is placed at Q. It seems. Q is placed somewhere in the middle. Okay, one charge is there. So if, for example, from A to B the distance is R, then Q to Q, if the distance is R, then Q to small q, the distance will be R by 2, and this also R by 2. Right? So this is how it will be. Now what we will do is, the net force acting on the body means it is in equilibrium, he said. Equilibrium meaning what? The net force acting will be equal to 0, right? What will be the net force here? Net force is the charge, if you take one reference charge, the force acting on this in between these two, and the force acting in between these two. That means 1 by 4 pi epsilon naught q square by r square, means force acting between q and two capital Q's, plus 1 by 4 pi epsilon naught q into q by, it's not r square, it is r by 2 whole square. Right? Now you can take, if you simplify, and this is equals to 0, because net force acting on the body is equals to 0. So 1 by 4 pi epsilon naught q by r square, if you take common, then the total thing will be equal to 0. And what will be remained here is capital Q will be remain, and this is R square by 4. No, this 4 will go off up. Then plus 4Q is equals to 0 it will be. Right? We want Q actually, isn't it? I am doing directly here. I hope you are able to understand. I have taken 1 by 4 pi epsilon naught capital Q by R square as common. Okay. Then if you take that, what happens is from this Q will be remain, and from this 4Q will be remain, and 1 by 4 pi epsilon naught Q by R square will go right hand side, means it becomes 0. So as the net force acting on the body is 0. Right. Okay, so this is 0. We want what? Q, small q we want. That is 4Q is equals to minus Q. That is Q is equals to minus Q by 4. So when Q is minus Q by 4, then this particular system of 3 charges, one is capital Q, other one is small q which is placed in the middle, and the other one is Q again. All these will be in the equilibrium position. So this is what the problem says, right? So I hope this one is clear for you, right? So the next one, if you take, so this is about the force, Coulomb force. We will do more problems, but before that, let me again tell you or remind you about the Spark Academy app. Just go to the Play Store, download, type Spark Academy, download the Spark Academy app. Okay, you will see like this, right? With the symbol of Spark Academy. Okay, download the app. Once you download, there will be some home page. What it consists of? See, it consists of the free handwritten notes, free study material, previous year question papers, questions which are solved, and the free mock tests. Okay, so all these will be there in the Spark Academy home page, right? And then, link will be in the description of Spark Academy homepage. If you click on the link, you will be directed to different courses which are offered by Spark Academy like this, right? So, what does the Spark Store consist of? What are the courses? Spark Academy offers long-term courses, previous year solutions, like even that also you can buy actually, crash courses, full-length tests, mock tests, and study materials. Okay, so you can buy all these, and all these are for JEE Mains, NEET, EAMCET, IIT Foundation, and IELTS. Right? Spark Academy offers classroom coaching. Yeah. Spark Academy offers classroom coaching. Classroom coaching consists of, classroom coaching means offline courses. It consists of short-term coaching, that is from 10 to 4, regular coaching from 6 to 9, right? And there are crash courses also which are coming soon. And all these offline courses are available in Naranguda and Medipatnam branches. So we have even online coaching also. This is NEET 2022 online course, JEE Mains online course, and then EAMCET 2022 online course. And as I told you, right, you can apply the coupon. Coupon code ANU. Apply this coupon code ANU and get the amazing discounts. On demand, we have live sessions, right? And all these videos, whatever are there, the live videos during the online courses will be stored, saved in the Spark Academy app. And if you miss any class that day, online or offline, whatever it may be, both are available. and if you miss any course that day, any class that day, then you can attend, you can just go to the app and see the video again. Okay, once you have missed, you can see it at any time, right? Or if you are having any doubts and you want to clarify, you want to listen that lesson again, then you can go to the app and then all the videos are available. You can just click on any of the video, whatever you want to, you wish to see it again, and then go through the class again. Okay, so this is the advantage of it. And then we have assignments. Everyday assignments will be posted online, and we have online like this. Okay, and online only you can submit your assignments, and we have tests. Online tests will be conducted every week, and the test syllabus will be posted, and test papers also will be posted online. You can just go to the app, and then you can attend the test also, and the result will be displayed in this way. The third one we can see. What is our methodology of teaching? Methodology of teaching is basic concepts, shortcut methods, all model questions, exercise questions, previous year question papers, chapter-wise tests, weekend tests, grand test, and test analysis. And this is the methodology how we lecturers teach in Spark Academy. And why Spark Academy? Because we have highly experienced faculty, personalized coaching will be available, and process oriented coaching, personal mentoring and doubt clarification, and limited batch size. So these are the advantages of Spark Academy. If you enroll your name in the Spark Academy, then all these advantages will be there. Okay, right. So what is the difference between online and offline coaching? Online coaching, there is no access to the classroom, but offline coaching we have access to the classroom. And online coaching and offline coaching, both access to online will be there, and then books will be available for offline coaching in the classrooms, but online no books, but study materials will be provided, and online study materials will be there in both the sessions you can use. And then weekly test will be there online and offline for both the sessions we have, and grand test will be conducted whether it is offline or online. Grand test will be conducted, and then weekly doubt clarification sessions will be there, both whether it is online or offline. Online means personal, definitely that personal uh, availability will be there. Where offline also we clear the doubts, but it is through online mode only. Okay, so this is about the Spark Academy. Right. Now, let us come back. We were discussing about the problems numericals solved in this electrostatics, right? Okay. So the next problem we will see. Two charges of plus 200 microcoulombs and minus 200 microcoulombs are placed at the corners B and C of an equilateral triangle ABC of side zero point 0.1 meters. The force on the charge 5 microcoulombs placed at A is. So for this, what we will do is, we will just draw the diagram first. Equilateral triangle. Okay. ABC. Equilateral triangle ABC will be. What is the side here? What is the length of the side here? Length of the side is 0.1 meters. I think they gave, 0.1 meters. Okay. And let us suppose there is a charge of 5 microcoulombs which is placed at A, and here it is plus 200 microcoulombs and minus 200 microcoulombs, right? So here plus 200 and plus 5 microcoulombs, there will be a vector which is acting from this charge and then which is going in this direction, and these two are attraction, isn't it? Because this is positive charge and this is negative charge, attraction will be there. So naturally what happens is the direction of the vector will be in this direction. Okay, so what is the angle between these two charges? The angle between this is 160, right? Okay, so this will be 60 and this is total one is 120 degrees. Resultant will be of 120 degrees. Like, this is one vector and the other one is one vector. Resultant will be in this way, obviously. I mean, what do you call that as? A parallelogram law of vector. That, I mean, when two vectors of tail to tail are attached, and then the resultant will be in this direction, and the angle between them is. Now what happens is, this is, let us suppose this is F1 and this is F2. Obviously, 205 microcoulombs, 205 microcoulombs, magnitude of F1 and F2 will be same. So which is equals to F. Now what is the resultant here? Resultant Fr is equals to under root of F square plus 2F square cos 120. Cos 120 is minus 1 by 2. So you will get under root of F square plus F square is 2F square plus again 2F square into 1 by minus 1 by 2. 2 gets cancels. 2F square minus F square will be under root of F square is F only. So resultant will be F only. So we need to find out F. If you find out F, that will be resultant. So F resultant is equals to F is equals to 1 by 4 by epsilon naught Q1 Q2 by R square. Right? That is 9 into 10 power 9 into Q1 is nothing but 200 microcoulombs. No, that is, we have to convert it into coulombs. That is 10 power minus 6 into 5 into 10 power minus 6 by R square, 0.1 whole square. So this is 9 into 10 power 9 into 200 5s are, that is 2 5s are 10, that is 1000 I can write 10 power 3 into 10 power minus 12 by zero point 0.1 into 0.1. This goes off, I think. 9 plus 3 is 12, right? This plus 12 minus 12 will go off. This will be 900 Newton. So in this way you find out the resultant of three charges, where two charges are of same, and then other one third charge is at one corner of an equilateral triangle, right? So this is one form of finding out the resultant. This is one method. We will just go to the another method how to find out. Okay. Same way you can find even the electric field also. Once you learn how to find force, Coulomb force, electric field is nothing but M by Q, isn't it, right? Only one Q will not be there, but the thing is remaining all the simplification will be same. Right, the next one we will see, next example. Three charges minus Q, plus Q and minus Q are placed corners of an equilateral triangle of side A. The resultant electric force on a charge plus Q placed at the centroid O of a triangle is. So what he is saying is there are three charges minus Q, plus Q and minus Q. So they are placed at each corner of the equilateral triangle, and we need to find out the resultant force acting on it at the centroid. Okay, we'll draw the diagram again. This is the centroid, right? Let us suppose we are placing minus Q, Q, this is plus Q, and again one more minus Q is there, no, minus Q, right? What is the side here? The side is A. So this side is A, this side is A, and this side is A, right? Now we need to find out the resultant at the centroid. Same, what is actually, this is minus, and like this, there will be force acting, and this is minus, right? This is plus, meaning the resultant one vector will be acting in this direction, other vector will be in this direction, and the resultant will be acting in this direction. Okay, so the resultant will be, because two forces acting on O, this one, from each side, right, up, down and all that, OB, OA, and let us suppose this is O, and this is A, this is B, and this is C. Okay, then angle between OA and OB will be, this is OA and this is OB, right? The same way how we have done, right? OB will be 120. Okay, so the resultant FR is equals to under root of, magnitude anyways will be same, even the signs only are different, right? So F square plus F square plus 2F square cos 120. Same way, we get that only. Fr is equals to F only we will get, right? So in between these two, but one more will also be there. No, here one more force is also there. So the net force acting will be resultant force plus the force which is acting on this OC, right? So this will be actually 2F. This is F and this is also F. F plus F will be 2F. So now the total net force acting will be what? 2 into 1 by 4 pi epsilon naught Q1 Q2 by R square. This is 2 into 1 by 4 pi epsilon naught. Q1 Q2 is nothing but Q square only. But what is R here? R is nothing but distance from this point to this point, because centroid, no, isn't it? So if you solve, usually R will be A by 3. Each side is A. From here to here it will be A by root 3. Okay, so if you solve it, you will get A by root 3. So directly I am writing here A by root 3. Now just find out. Okay, so this is F net is equals to 2 into 1 by 4 pi epsilon naught A by root 3 whole square, sorry, Q square by A square by 3, isn't it? This 3 will go come up, then it will be 3Q square by this 2 1 ja 2 2 ja 2 will go off, 2 pi epsilon naught A square. So this is the net force acting on the body. Okay, on a charge which is placed at the centroid, right? I hope this part is clear. Okay, so the next one we will see, like one more thing we will see on electric field. Like as I told you, like it's same. The problem solving is same both on the electric field and the force also. We will see how to solve problem in the electric field. Yeah. The electric field at 30 centimeters due to a charge of minus 8 nanocoulombs at the origin is dash. Okay, so we will draw the diagram for this. Minus 8 nanocoulombs it seems. Okay, so it is actually at the origin, and at 30 centimeters you need to find out the electric field there. Let us suppose this is the origin, right, along x-axis and along y-axis. Okay, so where the body is, where the particle is somewhere, it will be here, 30 from x-axis, 30 from y-axis, isn't it? And the force will be acting in this way. Now we need to find out the electric field. So how do you find out electric field here? Like we don't know R, isn't it, right? We have to find out R in the magnitude. Exactly we don't know what is R, but in the vector form I can write R bar as 30 I cap plus 30 j cap. Now take the magnitude of R. R magnitude is equals to under root of 30 square plus 30 square. So how much you will get here? 30 root 2 you will get. 30 root 2 centimeters. He gave in centimeters, but we need to find out in SI system. So you will get 30 root 2 into 10 power minus 2 meters. Right? So now we will find out the electric field. E bar is equals to 1 by 4 pi epsilon naught q by r square. In the vector form, what did I say? Q by r square, r cap I said. I hope you remember this. Or in the vector form, you get the formula as 1 by 4 pi epsilon naught q by r cube into r bar. Okay. Now we will elaborate this. E bar is equals to 1 by 4 pi epsilon naught is 9 into 10 power 9 into Q is how much? Minus 8 nanocoulombs he said. Meaning nano meaning 10 power minus 9. Okay. So 8 into 10 power minus 9 coulombs. I am not taking the charge minus into consideration. Okay. By r cube, not r square. So it will be 30 root 2 whole cube into 10 power minus 2. Otherwise, I'll do one thing. We'll write like this. What is r in meters we got? This one. So as it is, we will write. (30 root 2) into 10 power minus 2 whole cube into r bar. R bar is 30 I cap plus 30 j cap again into 10 power minus 2, because this is in centimeters. Again you need to do that there itself. So now we will simplify this. 9 into this 10 power 9 and 10 power minus 9 will go off. 9 into 8 by 30 root 2 whole cube, right? That is 30 into 30 into 30 into root 2 is 4 into root 2 whole cube, no? Into 10 power minus 6 it will be. Into, this is, if I take 30 common, it will be I cap plus j cap into 10 power minus 2. Right? So this 130 will go off. 130 will go off. Yeah. This is 4 1 3 2s are how much? 6. 6 by root 2 into this 10 power minus 5, 4 minus 4 it will be. This 6 into 10 power minus 2 I cap plus j cap. So this minus 4 comes up, it becomes plus 4. Plus 4 minus 2 will be 100. Right? That is 6 into 100 by root 2. No? What I'll do is, I'll multiply up and down with root 2. This will be how much? 2 into 2, root 2 into root 2 will be 2. This is 3. I hope I don't know if I don't know if I do it correct. Just let me check once. 9, right. This is 30. Fine. This is 30 into 30 into 30. Into 4 root 2. Yes. Not 4 root 2. Sorry. This is 2 root 2. Oh, yeah. So 1 2 will be there already. So this will be 200 million. Sorry. 200 you will get there. Okay. So this is how we will find out. We will find out the electric field in a plane, actually, when the when it is given in this way, um, when the particle is in plane at 30 centimeters from the x-axis and 30 centimeters from the y-axis, right? So this is how we find out the forces, and this is how we find out the electric field in the electrostatics in when it is given in the vector form. Okay, I hope this is clear. If you have any doubts, you can just post it in the comment box section, or you can just download Spark Academy app, and we have the chat session in the Spark Academy app. So you can just post your doubts in the once you subscribe, once you enroll to the crash courses, you can just ask doubts in uh, Spark Academy. Okay, so this is how it is. Can you call me after 10 minutes? Yes, this is about the Spark Academy YouTube classes. Okay, and as I told you, you can ask your doubts anytime, right? Once you download the app, okay, it will be helpful for you. Just download and subscribe to our Telegram channel also. Always the subject oriented discussions and information about the competitive exams will be done there. You just download the app, subscribe to our YouTube channel, subscribe to our Insta page, Telegram, and all that. All the information about the coming competitive exams you will have there. Okay, right. So now this is about the Spark Academy, and as I told you, just subscribe to our channel. And this is about the chemistry sir, math sir, and yeah, physics, biology, and then chemistry, math, and again physics. This is Anupama. This is what you are viewing through our YouTube channel, and these are our previous year Spark Academy EAMCET results. You can see every year the growth is there, the percentage of the students securing in the top engineering colleges, you can see here. And congratulations to all the students who have got very good results in our 2021 Telangana EAMCET. And this is about the NEET results, 2021 NEET results. 2019, 2020, 2021, we have got 19 seats in our medical colleges, right? So this is about the Spark Academy. Subscribe to our YouTube channel, and I hope this particular class is useful for you. And yeah, we will come out with a new topic and new chapter in our next session. Until then, thank you all, and thank you all for